Welcome to This Explainer. Okay, today we're diving into a genuinely fascinating mystery. We constantly hear about what AI can do, right? Acing the bar exam, writing flawless code, generating these crazy award-winning pieces of art. But today, we're looking at its hard cognitive limits. We're going to figure out why an AI can write a beautiful sonnet, but structurally, it literally cannot invent relativity. Which brings us to a really provocative question. If large language models are so brilliant at math and coding, could they have invented general relativity? I mean, think about it. If we gave an AI system virtually unlimited compute power, plus, all the data in the world, could it actually parallel the sheer paradigm-shifting genius of an Albert Einstein? It's a question that gets right to the very heart of what creativity and scientific discovery actually mean. To really wrap our heads around this, let's look at exactly where we are right now. In 2025, AI achieved gold-level performance in mathematical Olympiads. That is huge. They can navigate these incredibly complex symbolic rules with breathtaking speed. But here's the catch. Despite this immense deductive power, current generative AI just cannot make the cognitive leap required for true scientific invention. It's like they can solve the puzzle perfectly, for sure, but they absolutely cannot invent the rules of the game itself. Section 1. 3 modes of reasoning. Okay, let's dive into this. To see exactly why this limitation exists, we're going to use a framework by the philosopher Charles Sanders Peirce. He categorized human reasoning into 3 distinct modes. First up, we have deduction. This is basically taking an established rule and a specific case to predict a result. AI has absolutely mastered this. It's how it executes code, how it verifies truth. Second, we have induction. This is looking at vast amounts of cases and results to find a general rule, essentially statistical pattern matching. Generative AI is obviously famous for this, right? It compresses huge data sets to find patterns. But then, we have the third mode, abduction. This is taking a rule and a result to infer a completely new case. And here's the kicker. Modern AI fundamentally misses abduction. Abduction is that creative leap. It's inventing a cause for a singular, surprising phenomenon when there's literally no prior data to rely on. Now, what's really interesting about this slide is this is an actual diagram Albert Einstein himself drew in a letter to his friend Maurice Solovine. He was trying to map out his own personal cycle of discovery. If you look at the bottom, E stands for raw sense experience. Way up at the top, A stands for a system of axioms. And connecting them is this big, sweeping arrow labeled J, the jump. This is the abductive leap. Einstein literally jumped from raw physical sensory experience directly to a brand new axiom. You see, there was no massive data set of symbols for him to compress. He had to invent the concepts entirely from scratch. Section 2. Einstein's elevator thought experiment. So how exactly did Einstein make this massive jump when there was literally zero math to guide him? Well, imagine for a second you're inside a sealed elevator, floating way out in deep space, and suddenly, boom, it begins accelerating upward. What do you feel? You feel that visceral, physical sensation of the floor rushing up to meet your feet, right? Your body naturally reacts to it. This is what we call manipulative abduction. Einstein used this very real sensory experience to realize that the physical feeling of acceleration in space is absolutely indistinguishable from the feeling of standing perfectly still in Earth's gravity. And this sensory realization led to what Einstein famously called his happiest thought. He realized that for an observer falling freely from the roof of a house, there exists no gravitational field. The observer, therefore, has the right to interpret his state as at rest. This intuition is what allowed Einstein to anchor abstract mathematical symbols in tangible physical simulations. It's this deep, embodied grounding in physical reality. Now think about a text-based AI. It fundamentally lacks this. It doesn't have a body. It cannot feel the floor pushing against its feet, so it absolutely cannot use that feeling to invent a completely new physical rule. Section 3. Why data compression fails. So, the crucial point is, if AI can't physically feel the world, how on earth does it attempt to be creative? Well, the prevailing theory in machine learning right now frames creativity as basically data compression. AI needs massive data sets and super clear error signals to learn and correct its predictions. But let's think about Einstein's discovery environment for a second. When he invented general relativity, Newtonian gravity wasn't failing. There was no massive data crisis happening. Newton's laws were incredibly robust, accurate to a margin of error of like 10 to the negative 9th power. To put that into perspective, that is a vanishingly small error. There was no massive error signal driving his discovery. Einstein wasn't just compressing noisy data to fit a regression curve. No, he was constructing a completely new logical framework for reality before the empirical data even existed to prove it. Which brings us to a pretty famous philosophical concept called the Chinese room. It basically describes a system that manipulates language and symbols perfectly, but without any actual understanding of the physical reality or the sensory reference that give those symbols meaning. And current large language models are essentially just high-dimensional Chinese rooms. They can process the language of physics flawlessly, they can spit out the equations of relativity all day long, but they completely lack the physical prior to actually feel, perceive, or simulate the reality that those equations represent. They know the word gravity, sure, but they have never actually felt the sensation of falling. Section 4. Building interactive world models. Let's move to and see how this builds, because if just processing text isn't enough to achieve true scientific invention, what exactly is the missing piece? Well, the answer lies in a major paradigm shift happening right now in AI research. Simply put, passive visual prediction is not enough. I mean, you can train an AI on millions and millions of videos of falling apples, and yeah, it'll correctly predict an apple falling, but that's only based on statistical correlation. True invention, that requires action controllability and counterfactual intervention. The AI actually needs to be able to interactively manipulate the simulation to test what happens when you just completely change the rules. And this brilliantly illustrates how a future system might actually pull this off. Think of it as a three-step process for an action-controllable world model. Step 1, simulate a physically consistent world. Step 2, intervene counterfactually. Going back to Einstein's thought experiment, this basically means conceptually cutting the elevator cable. And then step 3, observe the sensory consequences to abduce new axioms. This kind of interactive world model acts as a synthetic laboratory. So instead of just reading text on a screen, future AI could use this interactive space to test physical intuitions, physically manipulate virtual environments, and actually experience the feedback necessary to generate completely new rules. So what does this all mean? Well, it leaves us with a truly fascinating final thought to wrap up this explainer. Will the next Einstein be an algorithm living inside a physically consistent video game? If historical scientific revolutions require that abductive leap, that jump from sensory experience to brand new axioms, then perhaps the future of discovery requires AI to not just read our scientific literature, but to actively simulate, control, and intervene in a virtual physical world. It is an absolutely incredible concept to ponder. Thank you so much for diving into this with me, and I really hope it leaves you looking at both human genius and artificial intelligence in a completely new light.